Another source of confusion when doing an uncertainty analysis is the standard deviation of the population versus the standard deviation of the mean. In particular, people ask me, which one do I use? Well, don't worry, that's what we're going to explain in this video. So let's say you're making measurements of something. Let's say you're measuring how long the hair is of people in your class. Now, they're not all going to come out the same. They have different values. And they're going to be spread over some sort of range. There'll be a mean somewhere in the middle, and there'll be some sort of range from the longest hair to the shortest hair. And the standard deviation is a measure of the range, of how spread out these points are. So a large standard deviation means people have both very long and very short hair. A small standard deviation means it's not much. How about the standard deviation of the mean? Well, let's think. The best way to think of this is that interpret the probability distribution function as your knowledge of something. So let's say you're trying to measure, I don't know, how fast the universe is expanding. Now, to begin with, you might have that this might be the expansion rate, and this is the probability. Now, to begin with, before you've made any measurements, you might have absolutely no idea. So your curve is going to look something like this. The expansion rate could be anything. But now let's say you make a measurement. And let's say your measurement comes out here. Does that mean the expansion rate is this? Well, no, because there's an uncertainty in the measurement. What it means is we now think it's going to be something like this. So the most likely value for the expansion rate of the universe is the one of your measurement, but it probably won't be exactly the same because we know there's an uncertainty in the measurement. And the width of this is the standard deviation of the population. But now let's say we make a second measurement, and the second measurement probably won't come out exactly the same as the first. Say it comes out over here. Well, now, what's our best guess for the expansion rate of the universe? Our best guess now is going to be the average of these. So it's going to be in here somewhere. And because we've now got two measurements, we have better understanding. So our probability distribution function, our uncertainty, has got smaller. It's turned into a narrower normal distribution. And then if we get more measurements, a third measurement might come in here, and each time we get a new measurement, our mean will shift slightly, and our uncertainty will go down. So as we make more and more and more measurements, the width of our ignorance, the width of our range of possible answers gets smaller and smaller, focused around the average, and the average will jump around slightly as you get smaller and smaller. And that's what's captured by the standard deviation of the mean. What that's telling us is that if we have a whole bunch of data points, the mean, the average, is going to be a more accurate representation than any one of the data points by themselves. And the uncertainty in those averages is the uncertainty of the individual data points divided by root n. So as you take more and more data, so n gets bigger and bigger, the uncertainty in the average gets smaller and smaller. So, if you want to know how accurate your mean value is, use this. If you want to know what range you get across the entire population, use that. So let's think some examples where you might use them. So over here, standard deviation of the population, you normally use that if you want to know what fraction of the objects have some particular property. So for example, let's say you're firing arrows at a target. You might want to know what fraction of the arrows hit the target. Now that is going to be something you'd use as standard deviation of the population, because you want to know there's going to be some distribution function of where these things land, and you want to know what fraction are going to miss. How about the standard deviation of the mean? Well, in this case, you typically use it when you're comparing the averages of something. So for example, let's say you're asking if you use a new bow, on average do the arrows fall higher than with the old bow? In that case, you're not asking about the individual shots, but you're asking about the average. You might take lots of shots with the new bow and lots of shots with the old bow and see whether it makes a difference. So it could be when you're firing things with the new bow, you get something like this, and with the old bow you get something like that. So they overlap, but the averages, if you've taken lots of data points, will be more precise, so the uncertainty in the average might be something like this and like that, and they're clearly different. So this is normally used for testing for differences in the mean of samples. So usually you use a standard deviation of the population if you want to know what fraction of the population lies inside some range or outside some range, what fraction are going to miss, what fraction are not going to fit, what fraction are going to cause a global financial crisis. And you use the standard deviation of the mean when you're trying to say, on average, does eating peanut butter make you fat? Or on average, does investing in the stock market make you get less? Or something like that.